Welcome, everybody. I got into 3D printing several years ago, and at the time I wasn't it was a fairly new hobby, and I wasn't up for unsupported software, so I didn't even try using OpenBSD or any BSDs as part of the process. I quickly kind of shifted into doing some design work on my OpenBSD laptop, which we'll talk about. But more recently, Michael Dexter, that reminds me, Michael gave me his little bust here so that he could attend. Got a 3D printer, and he's been printing himself. And we were talking, and my friend Brandon Mercer, B. Mercer at OpenBSD, has been printing stuff for quite a while. And we were talking about what was possible on the BSDs. And I was like, well, I don't know, actually. I haven't tried it. And so let's find out what that is. And so with the kind of changes that are happening with Windows 11 and 10 going out and all of this, I was like, that was really a good idea to try and get rid of all of that. So in any case, I'm Andrew Hewus Fresh, A-Fresh1 at OpenBSD, but that's not super applicable to this talk. And I realized that I should have been trying to figure this out much sooner, because we could be a lot farther along, because we're not. The main state is that it could be a lot worse. I have this positron 3D printer that I brought with me, and I printed all of the parts for it, sliced them all, and designed some extra parts for it, and printed the ones that are on it from OpenBSD. And so I was able to actually do all of the things, but I had very limited choices as to which software I could use to do that. As far as the design side, the slicing side, and that sort of thing. Just very little choice. Before getting into it, I'm going to talk a little bit about what I have so you can kind of see my experience and where I came in, and talk about what is out there. There are kind of three main types of 3D printers that are accessible to people in different ways. The main type, the most common type, is the FDM printers. They take a filament, they melt it, and they squirt it out of a nozzle in layers. And that's what you'll see most of the time. That's what all of the printers I have are. There's also SLA printers. Those are super common. They take a vat of goo that you have to be careful with and not spill. And I'm not very good at not spilling things, so I don't have one yet. Eventually, maybe. We'll see. They do a much better, they have a much higher resolution, can print much finer detail on things like that. But that's not, and that's really important if you're printing something for display purposes and stuff. But most of what I design and print is for, is more functional, generally. The other type of printer is SLS printers, and although I did see that somebody is hoping to come out with one that's only $20,000, they're not really common for home use. But once you have something that you've printed on, say, your FDM printer, and you want it to be printed in a higher strength material, such as metal or just a higher quality plastic, SLS printers can do that. And there are services online that will take the files that you have for printing on these other printers and print them in out of a different material for you. So that's really nice. I want to mention the other sorts of things that are involved in kind of home manufacturing, home computer-aided design sort of stuff. And those are either lasers that will cut or engrave or etch onto a material, or CNC, which is a router that the computer moves, controls and moves to different places to route out and cut out designs out of materials. And I mention those because a lot of the same design tools that you use for 3D printing can be used as in the same way for either laser or CNC as well. So if things really go well with getting 3D printing working well, then we'll want to expand and have the ability to do those other things because we'll be pretty close, I think. At home, I started out with a SnapMaker 2.0 printer. It's a printer that not only has a print head, but it also has the ability to add a laser head or a CNC head to it. The original one I got, I only had the print head. And then I later added the laser, and I was doing all this with their official software on the Windows machine I had dedicated just for this. And I did try at one point to see if I could port that Lubon software that SnapMaker has, and I ran into some dependency it had that I only found binaries for, and so I kind of gave up and didn't ever get back to until now. SnapMaker came out with a higher quality CNC head, the router head for it. I was like, oh, I want to try that. And reasons, I ended up, instead of just adding that, had to get I got their newer, larger, higher end printer, and with the CNC included, and then tried to sell the old SnapMaker, and I'm terrible at selling things apparently. So, and then gave it to a friend of mine, and he and his kids have been having fun with it. So I guess that's good. Lisa was sometimes wanting to print while I was printing, and so she found the AnchorMake Kickstarter and was like, oh, this sounds really cool. They're going to have 6 different color change options, and it's super fast and really nice. And so got on the Kickstarter, and that printer is nice, but then they canceled the multicolor thing, and now it's a nice extra printer to have, but it doesn't have the promise that it had. I recently then just kind of wanted, of course, but after getting the talk accepted, decided I needed to have the positron, which is the printer that folds up and can be taken as a carry-on, or even get checked if they decide that they don't want to let you carry it on because the box is too big or something. Anyway, so I brought a printer with me to kind of show off while I was here. And to that end, there are really 2 hobbies when it comes to 3D printing. One is building and tuning and printing parts for and designing parts for 3D printers and trying to make your printer work better. And the positron is kind of much more that style of printer. It's been a very big learning curve of kind of how the underlying technology works and how to make a printer that is developed by the community kind of work and have good prints and everything. So that's been kind of fun and exciting and an enjoyable learning curve, but I was supposed to be writing this talk instead, but instead I was learning about a printer. The other side are the other printers we have, and those are kind of more big companies that it went through and did all the work of making it easier to tune the printer, and so you can just say, oh, I want to print this thing, and you have this thing, and you don't have to worry, like, oh, is it going to print? Mostly. It's not entirely true, but kind of. My brother-in-law has Bamboo Labs X1 Carbon. I think he just got the H2D from them, and they're kind of on the far side of away from the community-based printing, where they recently changed their licensing terms, and they claim they won't enforce it, but the way the licensing terms say is that some of the printer features may only be accessible through their software, and they have the option to require that their software is only available through a subscription service, which they aren't going to do, but obviously that's just the ability for them to do that is, kind of one of the trade-offs that you get through some of these printers. So, like I said, I want to try to get rid of the Windows machine that I'm using and replace it with using OpenBSD. And so I started looking at that. Brandon Mercer that I mentioned has been using Orca Slicer on, I think he uses it on Linux actually, but he enjoys it. He said it's a really nice slicer, and I wanted to try it. And so I started trying to port it and ran into some trouble, and then again started building this new printer and working on this talk. So haven't gotten back to fixing whatever the things were that were wrong with it, but hopefully I get back to that now after I'm done with this. So we'll get to that in a minute, because I wanted to mention the kind of categories that we're going to talk about. First are the design software, and those are the things where you have ideas and you turn them into 3D models on the computer. And there are several different types of those that we'll talk about. Then once you have that 3D model, and you technically don't need to design your own, there's lots and lots of people out there that are sharing models and sharing free designs, but also there are people that do designs that are that they sell, that are those are generally more the creative type models, the things that you would set on a shelf and have painted, and fancy things like that. Then there's the firmware for the printers, and I will mention that a little bit down there, and that turns the slicer software, so then I missed one. So then there's the slicer software, and that takes those 3D models, turns it into what's called G-code, which is the kind of instructions for how to move the printer head around, turn on the heating element, turn off the heating element, extrude more filament, that sort of thing. And those same, very similar G-code things are the same kind of commands that are used for all of those other sorts of things like lasers and CNC. So once we have kind of these things available, it's close to being able to do these things, not just with 3D printers. Then take that G-code, and the different printers have different firmware on them that turns that G-code into the actual hardware movement and all of that. And I want to mention some of that there at the end. We'll get there. And then there are all the little bits and pieces that go around printing that make your life easier and give you like status and stuff about the printer and what it's doing. So the things here in bold are available in the OpenBSD ports tree now, and things that you can go use and try out. And you don't technically, like I said, need to design any of this, anything. There's stuff available. And I tried out a bunch of these applications when I was getting started, and so then I figured out kind of what I like, which is OpenSCAD. But I tried out Blender, and although you can apparently do things like make award-winning, Academy Award-winning films in it, I am not that creative, and I don't really make creative things, and so I never really could get it to do anything that I wanted, but that's, I think, a limitation to me. I ended up using OpenSCAD, where it doesn't have any clicking and dragging and anything like that. You just type in like sphere or circle or cube and difference and things like that, and you write code that builds things. And I've had really good experience and very good luck, I think, with designing things. You can load in external files and stuff into it. The little coin things that are available, that are printing now and are out on the desk, I designed in that. I recently found out that solve space exists in the ports tree. I actually had never heard of it before. It was not something that ever kind of came up when people were talking about what things they use for design. And so I haven't actually tried it. People sort of explained it like AutoCAD 14, which I guess maybe makes sense for at least the people that I know who have used AutoCAD were very excited by that. So that might be an interesting thing to try. JTT has ported it, has put it in the ports tree. He was also working on a port of FreeCAD, which is definitely something that a lot of people use and has recently had a 1.0 release that has made things far, far better. And I'm really looking forward to that, to trying it out. And I'm supposed to be doing that and trying and figuring out what other things don't work in the port. But again, building a printer, working on a talk. There are some of the web-based design things. I tried some of them. They were all the same. Click and drag, make lines. You can say how big they are. You can say how they are related to each other, and a lot of them, people really like them. I have a hard time using them because you have to like make a straight line, and even with the computer's help, I can't do that. The most common software that people use is probably Fusion 360. It's like free until you start making several $1,000s a year from designs or something, and then Autodesk wants to charge you money for it. And of course, since they want to charge you money for it, it's not an open source sort of thing. So you probably will never be available unless somebody works at Autodesk and says, hey, we should make an OpenBSD version. One of the things I'm really hoping is, though, is that as much as I like OpenSCAD, they have not done a release since 2021, and they've been working really hard on it. But apparently everybody who's working on it are the people that are important. And so they have not considered that they should do a release until recently, because they just build it. When they're working on it, they have all the setup, and they just compile the new version, and they do it. And they do have nightly builds for both Mac OS and Windows. And I've been using the Windows one from time to time because, for example, they have a new renderer engine built that they have since 2021, where on the OpenBSD machine, it may take an hour to render something. On my Windows machine with the nightly, it will take just seconds, so, oftentimes. And it's the same if I ran the old version on Windows. So it's definitely the new renderer and stuff.
We updated OpenSCAD to that version.
To
FreeBSD ports.
To a nightly?
To whichever one has a new renderer. I've been pushing that.
Nice. I'll have to.
Maybe our work would help you.
I'll have to look over there and see what we can pull in, because since 2021 they also changed the whole build system, all of the dependencies, and I don't know, a whole bunch of other stuff. And so it was not just as easy as copying our existing port and updating some of the version numbers, which was kind of annoying. But yeah, if there's a starting point, I know that somebody said there was a starting point for OrcaSlicer over in FreeBSD as well. Ports also has some other 2D CAD packages that might be useful once we can design things for lasers and stuff. And sometimes you can design things that are in 2D that you can just extrude, and that works well. But like LibreCAD and QCAD are in there. Might be useful at some point. But the things I'm looking forward to are FreeCAD and hopefully getting OpenSCAD nightly port built. Next up on the list are slicers, and this is where things kind of fell down a little bit. Renato Aguilar did have Prusa Slicer, did port Prusa Slicer, and so that's kind of one of the kind of original, older, a lot of things have forked off of Prusa Slicer, even though Prusa continues support for it and continues adding features and stuff. But there are a few a few forks of it that people really like. The one that I mentioned earlier, OrcaSlicer, that Brandon Mercer really likes. Been trying to work on porting that, and I'm going to look at the FreeBSD work and see if I can use some of that. It is, of course, based on Prusa Slicer, so some of the patches that we have in Tree for Prusa Slicer were helpful to get further along, but it still wasn't quite working. Similarly, Super Slicer is just kind of a different fork, I think, of Prusa Slicer. I don't know that any of the, how much luck we'll have with any of the kind of more proprietary, I guess, versions that are also mostly based, I think, on Prusa Slicer, like the Anchor Make software or Luban, like I mentioned, for the SnapMaker that I have. And Bamboo Lab definitely is, I assume, is going to go out of their way to keep that from being easily done. SnapMaker is working on, has released, I haven't looked at it again, their own fork of Orca Slicer that is adding better support for their printers. They are working on, they claim that they're going to push all of their fixes kind of back into the main Orca Slicer, so it's supposed to be a friendly port or a friendly fork and that sort of thing, so that's exciting. I know that somebody asked me about Cura, and we don't have Cura yet, but I'm hoping we get that because the Creality ecosystem sounds really nice, and I'm sure that I know a lot of people have those printers.
So Cura is my favorite. FreeBSD again has ported it. The difficulty you're going to have is there's a new way. Someone just had to invent a new way of compiling very complicated Python things. It's like a new make framework, and it is the hardest part of the port when you're running. But Cura is not the only thing you're going to use it for in terms of your package system. All of the really complicated Python things are using it now.
Yeah, so he says that there's Cura is available again in the FreeBSD ports tree, and it uses some sort of complicated build system for Python. So again, somewhere to start to get it into OpenBSD. Kirimoto is not only available on the web, it's a thing that you can run on your own web server, so that was kind of neat. That'll be kind of a cool thing to have available. It worked fine-ish. It didn't have profiles for any of my printers. So although I tried slicing something, I didn't actually print it. It imported the models and worked fine. Again, also only saw DXF to G code because I thought, I wonder what else is available while I'm making this talk. So Tracy Emery imported that, and it looks like it's a neat slicer-y kind of thing. I'm not sure exactly. But it's another thing that came up while I was looking at this, and this talk has added a whole bunch of other things to my to-do list to go look at and to try. So hopefully somebody else is interested in doing that and can maybe port Cura or Super Slicer or something that would be neat for me to try and then not have to do that. Next up here is the kind of printer firmware, and that's not really OpenBSD specific, I guess, mostly. Because pretty much all of these are GPL v3, and sure, I'm sure that OpenBSD has compilers, so I'm sure that you can compile the firmware and copy it to the printer and all that. But I did want to mention that there are different types of firmware and different sources of firmware, because a lot of like my SnapMaker and the Anchor Make, I believe, are based on the Marlin firmware. And that one is kind of a more complicated firmware. It does all of the things in firmware, and so everything runs on the microcontroller, and means that people who are doing a large number of printers can pay somebody to do a little more work in the software to work on the printer, and then the printer hardware is cheaper. Whereas in the community-based printers like the Positron here, that uses Clipper, which is a very much more lightweight firmware that runs on the microcontroller, and then it takes a external kind of server written in Python that runs on a computer somewhere. If you can see the positron, that little screen that's sitting next to it is actually a Raspberry Pi running Linux and running the Clipper software. I'd really like to eventually replace that Linux on there with OpenBSD and have it run that way. I don't see any reason that shouldn't be possible. So it sounds like a kind of fun project to have all of the kind of some of the Clipper infrastructure in the port string to be able to run that.
I was going to say you should add duet3d.com to your list. That's a fully open source, and it's a different. I mean, they're capable of like a polar. It's a really capable firmware, and it's fully open source.
Oh, nice.
Even though they make the electronics, and they've been fighting with Chinese people making electronics, they're compatible. They've still stayed open source.
Nice. We'll have to go look at that. Duet 3D, he says, is another firmware. And apparently there's a bunch, because I learned about this RepRap firmware. I mean, I knew about RepRap. I just didn't know that they still were around, I guess. They were kind of one of the original self-replicating printers where the design was you 3D print all of the parts for the printer except for some of the metal parts. And then you can print, once you've printed those, you can build it, and then you can print another printer. And that was one of the things that got the kind of hobbyist 3D printer movement started, I think. So the RepRap firmware I found out about because I was watching a video of someone doing a non-planar slicer, and he had designed it so that it could print non-planar, which means that instead of just moving one layer up and printing the next layer and moving one layer up and printing the next layer, it actually moves the print head in curves and in more directions while printing, which normal slicers don't do. And in order to do that well, he had to have a print head that would swivel and move around the print, and so to keep from crashing into it and stuff. And the RepRap firmware has support for the additional access to be able to do that. So that looked like a really fun printer to build at some point and try out. I know that Lisa was looking at trying and to order the parts, and our friend that I gave the SnapMaker to were all conspiring. So we'll see what happens there. Didn't want to mention that I'm sure that there are printers that are supported by multiple firmwares that you could probably run Clipper on printers that currently run Marlin, and possibly the other way around, though the space limitations, because it's a simpler firmware, might be different. I'm not sure. But in any case, once we have that, I wanted to talk about the thing that I found with the Clipper itself, is that because it runs so minimal stuff in the actually on the microcontroller, and most of it is running on written in Python and running on the computer, people have written a lot of plugins for it and things like that. Running on the Raspberry Pi over there is a Moonraker, which is a web API, REST API sort of interface that talks to Clipper, and then different things can talk to it to get status with the printer and to send prints to it and stuff. The touchscreen is being driven by Clipper screen, which talks to Moonraker, and so it can so it's displaying on that screen down there, but talking over a HTTP API to Moonraker, which is talking to the Clipper firmware, or Clipper daemon, which is talking to the firmware, and but it's really neat that you can have these sorts of things. Also running on there is Fluid, which is a web interface that also talks to that Moonraker API and lets you bring up the printer interface in a web browser on your computer from anywhere that you can access it. And that's really neat because you can check on the status and check on what it's doing and all of that remotely. And a lot of printers have that sort of functionality, but this was one that seemed like if you can replace the Linux that's underneath running on it, would be really handy to have available and kind of fun to play with. And there are lots and lots of other pieces and random things that you can do to make working with printers more fun and easier and that sort of thing. Like SM2 Uploader, which is SnapMaker 2 Uploader, is a Go application that knows how to talk to the SnapMaker machine's API and translates that, and so you can use that to send files over the network to that printer. And it also supports being a octoprint server, so you can, in a lot of slicers, like Prusa Slicer, it knows how to talk to that Moonraker, it knows how to talk to octoprint, and so once you've sliced your model in your slicer, you can just use a button to click to send to the printer, start a print directly from the slicer, which is really a nice step rather than having to save it to a file, copy it onto a thumb drive, take the thumb drive to the printer and all of that, which is what I do with the AnchorMake, because that one is a bit more of a proprietary interface that the AnchorMake, for its networking ability, talks out to a service running on Amazon Web Services, and then the software on your computer talks to that service on Amazon, and doesn't actually talk directly together, which is, again, a choice on their part that isn't necessarily one that I would make again. But there are lots of things that make kind of working with 3D printers and sharing and that much nicer. And so we need a lot, when we don't have many of those in the porch tree, so we need those either. And I went far, far faster than so I must have forgotten something, which means that hopefully you have questions, so that triggers my memory. And while you think of those, I'm going to mention that I'm in Portland, Oregon, so if you're generally in the US, because I wouldn't expect, would hope that nobody else is coming there right now, and you end up in Portland, hit me up. We do a social meetup. That's BSD.pizza has port nights to go there. Those meetings also get posted on Calligator, which is the Portland Tech Calendar aggregator. Also there is the plug meetings that Michael Dexter used to organize, but he turned it over to somebody else because he got busy organizing BSDCan or something, or finding money for BSDCan, whatever it is. And so they do more structured talks and things. And I wanted to say thank you to West 3D, where I got the positron. They have a really nice shop close by, and were really helpful with kind of having stuff available and getting me started and that sort of thing. So, questions, comments, other software I should write down that I should try? Oh, here comes a microphone.
Worst case scenario.
Oh, and if you don't get a microphone and I forget to repeat the question, somebody yell at me.
Right. So, yeah, I'm live. Just not a question, sorry, just more of an opinion statement, is particularly in the OpenBSD ports tree, it's, to me, one of its main advantages is not that every imaginable piece of software is in there, but rather, one or two really good pieces of software are in there. So I don't know that
Everything.
I'm not doing the work, so I don't care. But I don't know that going and adopting or getting into ports every single 3D, designing program, slicing program, etc.
I think
is necessarily a fit.
I think that's probably fair. I mean, I think that I would really love to be able to like run this printer, a Clipper printer, with the Clipper firmware or the Clipper whatever on that Raspberry Pi without having Linux on there. And I would love to have all that in the port tree so I can just package add Clipper or whatever, and it would just kind of work. Again, I mean, on that Raspberry Pi, all of those are just like Git checkouts of the Git repos, even on there. So again, it may just work, and you can do it the exact same way that it's done there. And maybe that's good enough. That's not the way I'm used to managing a system, right?
Does OpenBSD's X11 support touchscreen input from these little
I don't know
thingies?
that this thing actually, I'm not sure what interface this actually uses. I think it's just doing direct, some sort of, not X11, just like something. I'm not sure what it's doing, but it doesn't, I don't think that.
Oh, just frame buffer.
I think it,
Character-based alphanumeric.
Say that again?
Generally, those are character-based alphanumeric.
well, this one is, I mean, this one has pictures on it and stuff, so.
Oh, well, then maybe it does do that. I was gonna say that the Duet firmware uses like a RTOS or something to it. And because it's using RTOS, it's capable of like losing power and just before losing power, storing where it is and then coming back and starting to print as soon as the power is restored. I'm not sure that you're going to be quick enough on Linux to get that.
Yeah, possibly not. I know that my snap maker that is running Marlin fork, I guess, does that, has support for that. But yeah, I don't know that that the way that the Clipper is designed, it would be easy for that to happen, for it to have that power fail recovery. But it is a nice feature.
Does OpenBSD have any line support?
Does OpenBSD have wine support? I am not sure. It used to. It used to be in the port tree for sure. I don't have any idea if it still is.
The only reason I ask is some of the things like Cura do work under Wine, even if we do prefer to have them running natively.
I don't see a wine directory in my ports checkout, but it might be named something funny. Sometimes they do. But it also could have just not been working well.
I think they got rid of it.
Somebody says they think they got rid of it. That wouldn't surprise me. All right. Well, with that, it seems like I am interested in hearing more of your experiences and more pieces of software that sound cool that I would like to try out from people who have used them. So let me know, and thank you.